Okay, hello everybody, distinguished guests and ladies and gentlemen. Good morning, good afternoon, good evening. Our second AIW on air first webinar will begin shortly. So for all the participants, please turn on your video. And for the presenters, if you have a chance to speak, please check your mic to unmute. So we kindly request you select your language as English at the bottom of the screen. You can select the language. And then we will begin our webinar on time, on 4 p.m. So wait for a while, please. Once again, for all the participants, if possible, please turn on your video so we can see your face, and we can start our webinar soon. Okay, it's time for our webinar. From now on, we'll officially start our fourth webinar of second AIW on air. My name is Yong-Han Kim, and Planning Director of Asia Water Council, Secretariat. And it is my pleasure to see you again. And then I would like a special gratitude for all the participants, despite the big time difference for, as America, I know they are 2 a.m., so we are very thankful for them. And then, so today's theme is water, energy, food nexus. So we will invite 3 renowned experts and 2 panelists. So before to begin with, I'd like to our coordinator, who is responsible for with this theme, is Mr. Dr. Kwang-Sung Lim. Yes, he is in charge of this theme with our event. And to begin with, I'd like to introduce our K-Water Vice President, Mr. Dong-ho Che, as to deliver congratulatory remarks. He has more than 30 years experiences in K-Water, and he has many experiences. Chief Manager of Management Officer of Green Transition Promotion Division, and then he has many experience in water resources, infrastructure, operation, and management, and then he has a lot of experiences as well. So please welcome him with a big loud of applause.
안녕하십니까. K-워터 녹색 전환 추진단장 최동호입니다. 바쁘신 와중에도 제2차 아시아 5월어 이슈 온에어 세션에 참석해 주신 UN 워러 페데리코 프로포지 기술 고문님, 도어티 물식량 국제연구소 피터 맥코닌 국장님, 중국 수리수력연구소 용란주 박사님, 인도네시아 PJT 레니 마야사라이 박사님, 그리고 온라인으로 참여하신 여러분 대단히 감사드립니다. 이번 4차 AIWW 온에어 주제는 물, 에너지, 식량 넥서스입니다. 최근 기업 경영에서 ESG가 중요한 이슈가 되고 있으며 기후변화 대응에 대한 국민적 관심이 증가하고 있습니다. 이러한 ESG 경영이 실현되어야 하는 한 부분이 물, 에너지, 식량, 넥서스 분야라고 할 수 있습니다. 세계적으로 물, 에너지, 식량을 별개의 자원으로 생산하고 소비해 왔으며 물, 에너지, 식량은 경제 성장 및 발전의 필수적인 요소로 세 자원 간의 상호 연계성이 부각되어 왔습니다. WEF 요소는 서로 간 상쇄 효과를 통해 매우 밀접하게 연관이 되어 있습니다. 따라서 물, 에너지, 식량 정책의 효율적 관리와 더 나은 일관성을 달성하기 위한 정부 조직 등 거버넌스, 환경, 사회적 연계성을 이용하여 자원 간의 효율성을 찾는 혁신적 기술도 필요합니다. 한국은 물관리 이론화와 같은 거버넌스 계획을 달성하였으며 기술적인 측면에서도 수돗물 공급 과정에서의 관로성, 압력 에너지를 활용한 소수력 발전, 정수장 및 댐 수면을 활용한 수상 태양광, 해수 담수와 에너지 효율 개선, 수열 에너지 활용, 농업용수 절감 및 생산성 향상을 위한 비담수화 관계 등 다양한 새로운 WEF 넥서스 기술을 위해 노력 중입니다. 이번 세션에서 물, 에너지, 식량 세 가지 자원의 역할과 요소별 트레이드 오프에 대한 충분한 이해와 다양한 WEF 넥서스의 접근 방향 및 사례를 나눌 수 있는 소중한 자리가 되기를 바랍니다. 마지막으로 본 세션 준비를 위해 애쓰신 분들과 이번 세션에 참여해 주신 모든 분들에게 다시 한번 깊이 감사드립니다. 감사합니다.
Thank you, Vice President, for your meaningful remarks. Now, from now on, I would like to introduce our moderator, Mr. Federico Property. He is a chief technical advisor of UN Water, and then he has experience, more than 20 years of experience working in United Nations systems at regional and global levels. Please welcome him with a big round of applause. Mr. Federico, the floor is yours.
Thank you. Can you hear me?
Yes, good.
Okay. Thank you. Thank you very much. I saw there were, before we start, I saw there were some messages about the English translation. So I hope you're taking care of that. Just to allow everybody to listen also to the English translation. Okay, so good morning, good early morning in some cases, good afternoon and good evening to all of you. First of all, I would like to warmly thank the Asia Water Council for organizing this fourth webinar of the Asia International Water Week on air and for inviting me to moderate this session. It is a great honor. And many thanks to Mr. Deng O Choi for your words. Thank you. Thanks so much. As your moderator, I will accompany you through the presentation session and the panel discussion. We have a very rich agenda, so without further ado, let's move to the presentation session. Each presenter will have 10 minutes and I will introduce them, as in the order that we speak. So we have Professor Peter McCormick. Welcome. It is a great pleasure to have you, in this webinar. And we know it's in the middle of the night now in the United States. Thanks so much for joining us. Professor McCormick is the Executive Director of the Doherty Water for Food Global Institute at the University of Nebraska. where he leads the Institute in delivering on its vision of the water and food secure world, building its partnerships and collaboration in Nebraska, within the United States, and internationally. He's a tenured professor in the Department of Biosystems Engineering and a courtesy professor in the Department of Civil and Environmental Engineering at the University of Nebraska-Lincoln, and the Robert Doherty Chair of Water for Food. Professor, the floor is yours. You will give some reflections on water, energy, and food. Thank you.
Thank you. In terms of me seeing the presentation, how do I pull that up? Okay. Yes, thank you. Good morning or good afternoon, good morning. And to our Indonesian hosts, if we've been in Laban Bajo, Selamat Siang and Selamat Pagi. I started my career in very close to where our third speaker will speak to in my international career. So I'm very familiar with that part of Indonesia. When I was asked to do this, I wanted to reflect on some of the thinking around the water, food, energy nexus, and consider just how it's evolved and where we're going, and the sort of opportunities we have in this nexus. I think the early conversations around this were when we were considering IWRM and other things, what was the advantage of looking in this space and or looking at things this way and considering it. I think as engineers, we find that rather natural to do, but I think the main thing here was really to look for, it was more for finding solutions to find things to implement on the ground that was the real attraction to this. Next slide, please. As I reflect back on my experience with this, in 2005, while I was at the International Water Management Institute, we organized, along with partners, a workshop in Hyderabad. This was in southern India, in the drier part of India, or one of the drier parts of India. And it brought together researchers from IMI, other ICRISAT in India, but our Indian partners, the Indian agricultural people, the water folks from the States, and so forth. It also had the likes of Shell and others. This was the first time I'd really been in a conversation that brought the energy component in so strongly in that way. It was a really useful workshop, and one of the things that it really challenged me to think more about some of the parts of the world where I was working or had worked, and what some of the opportunities might be there around water and energy. I didn't really reflect on Indonesia on this one, but in terms of one of the places that I think is particularly instructive is Jordan. In the early 2000s in Jordan, it was already had reached 150 meters cubed per capita in terms of freshwater resources. So a very dry country at that. But the other part we don't hear so much about is Jordan is very energy insecure as well. It depends on hydrocarbons from other countries in the Middle East, mainly Iraq and neighboring areas. And if you now go back with Jordan, population growth, refugee changing, and refugee numbers, that number is now halved. So we're down to 76 meters cubed per capita in 2014. So certainly the numbers have dropped drastically. Jordan is very water insecure. And now much of the new drinking water has to be desalinated because it's brackish water, and it has to be pumped over 1,500 meters to where the population is in Amman. So it's a very tricky, dire situation. The trajectory there of where is that heading in terms of the agriculture? There is still agriculture, but it primarily exists on wastewater, reclaimed wastewater. There's then this energy, the very energy intensive water. And I've always used that as a sort of backstop to consider what does it mean as we make decisions in river basins? How does this change over time? And how will we address that going forward? Jordan is certainly, has to be a world leader in this because of the challenges they're faced in. I think India, if you look at India and the numbers, we see the same trend. Of course, India has got a lot more water per capita, but of course, much of that's in river systems like the Brahmaputra, a long way away, difficult to manage, very erratic flows. And then if you go down to the southern part of India, you see already areas getting very water scarce, of course, Rajasthan, but very similar challenges around hydropower. The agriculture has intensified. You see water moving up the river basins as they intensify agriculture and try to grow more food for the population in river systems like the Krishna. And even larger scale in the US. So if I look at the US, it's very water rich. But of course, we know there's parts of the US that are very dry. I will talk a little bit more about the state I'm sitting in now. When I was working on this work, I used the example from Idaho. I've left the references there if you're interested in looking in that. But now I want to talk a little bit about food and agriculture, and I'm going to use India as my example. So next slide, please. I'm particularly going to focus on the Punjab. I'm not that familiar with the Punjab. I've worked more in other states, but I think this is really the poster child. It's made a very important state when it came to the Green Revolution in the 1960s and the 1970s. And remember that India was very food insecure at that time and had to really try and transform its agriculture. And this was many factors: crop breeding, new roads, and so forth. But a big part of this, the intensification in the Punjab and neighboring states in that part of India, was around more reliable water supply, and that was in developing the groundwater. And this was done by really by the farmers putting in wells, but the electricity was provided either free or at very highly subsidized levels. Well-intentioned to try and develop and intensify agriculture. And Punjab really became a major state exporting food into other parts of India. This is really a lot of investment. But now it's today, and we hear a lot about this, is there's a significant issue with this free electricity that has allowed farmers to pump the water further down than would be financially possible for them. And it's producing, as Dr. Gulati argues in his paper, the water is still dropping at 700 millimeters per year in parts of the Punjab. And the yields are high, but the value of that crop is now much lower because it can be grown elsewhere. Rice is still an important commodity crop. It's still required, but the argument is we should be using this water for higher value crops. So it's really created a problem in terms of, and a recent colleague of mine in India said it's really the policy was the right idea in the 70s, but then the policies, the politics didn't allow the policies to be implemented to reverse some of the negative impacts of this. Next slide, please. So Nebraska, there's some commonalities between Punjab and Nebraska in terms of the food production. Nebraska is now the largest irrigated area in the United States. If it was a country, it would be ranked 12th in the world in terms of the area it's grown. If you look on that map, the blue is the Platte River. This is a big river that flows into the Missouri. It's about 1/5 of the Ganges in terms of overall flow. And underlying that is also what's called the High Plains Aquifer. It's really the part of the Ogallala Aquifer system. You hear a lot about problems in the Ogallala Aquifer, but actually this part of the Ogallala has been well managed. In the 1970s, Nebraska saw this issue occurring similar to what, not so much on the subsidized, but certainly had developed the groundwater. It was 7/8 of the irrigation is coming from groundwater. And then they implemented a system of natural resource districts to manage, devolved government of managing the water. And this has been expensive, but it's been successful. And now the groundwater levels in Nebraska have stabilized and in many places returned. There's still some issues, and certainly there's water quality challenges, but in water quantity, they are being quite well managed. I think it's still, on the flip side of that, Nebraska is also the 10th largest energy consuming state per capita in the US. And a big part of that goes to irrigation, despite improvements in the pumping, improvements in the systems, the changes in the center pivot systems that allow a much better, less consumption of energy for the unit produced. Next slide, please. So recently we did a study looking back at the 2000, it was looking back 30 years, looking at that timeline. It would be nice to do this for the Punjab as well, but the data sources in Nebraska allowed us to look at this, looking at what with maize and soybeans are the main crops here. And what really surprised me coming out of this, water productivity, the crop per drop, the consumptive use of the crop, not just the water being diverted, but actually what was passing through the crop. The actual yield per drop of water has been going up steadily over the years. And for 30 years, that's been an upward incline. And I don't think this was really intentional in terms of actually increasing production per unit of water passed through the crop, but this is really what has happened. And it's a fascinating trend, and it really truly is saving water in this basin. It's not just recycling water within the basin. So this is an important finding. It actually surprised me that this was so clear. And it's something that in terms of opportunities. Now, the downside to this, that actually the investments in the irrigation systems, the pumps and the center pivot irrigation systems, the technology provided the access to manage the agriculture better. It didn't truly save water. What saved the water is really the breeding and the crop management practices. So that's an important finding. Next slide, please. Just because we're meant to be in Indonesia today, and I'd much rather be sitting in Labuan Bajo with you all, but some of the work that one of our colleagues that works with us on this work in Nebraska, he has been working on the Yield Gap Atlas, and this really is looking, where are the gaps in the yield that we can increase the yield? We can actually increase the water productivity. And that's places like Punjab have done well, but there's still opportunities to improve there. And Indonesia, we see in rice, there's still, and that's across the whole country. We could drill down into parts of the country and look at that more carefully. But in terms of rice, there's a gap. We could increase with the same amount of water, and looking carefully at energy, we could produce more food without impacting other parts of the equation. Same with corn, maize. And of course, we're also looking at, there's quite a lot could be gained by the improved water management in food. So just in closing, next slide, please. This is a very broad brush overview. One of the points I really want to stress here, producing more food with less water requires investments in crop breeding and management. That's in addition to the roads and so forth. This is has been a big part of it. Indonesia's benefited from that. India's benefited from that. But the question I'm asking the breeders here in America and elsewhere is, can we keep doing this? Can we keep growing more food with less water and less energy? To achieve this requires investment in technology, and to sustain the resources requires the institutions. So the institutions that in Punjab have not been able to reverse the issue around the electricity. And there's many reasons, but it certainly comes down to also the politics. So it's something that can be very tricky. Some states have done better in India around this issue. Water saving technology and infrastructure may not save water, but it can reduce the energy requirements. So there's wins there as well in terms of the water food nexus. And what I'm really pleased to see this presentation from Pej Dua is the consider the trajectory. Where are we going with this energy, food, water nexus? Because we solve the problem now, but we must be thinking ahead 10 years and 20 years. Jordan is the sort of poster child for some of the situations we're faced with in the future. Thank you.
Thank you so much, Professor McCormick. I think I really liked how you positioned, you focus on today's challenges of the water, energy, food nexus, but also talking about solutions. And I wrote down, I liked when you said politics didn't allow the policies to be reverted, because what I also take home from your presentation is this need for balancing the technical, policy, and politics dimension of a water, energy, food nexus. So thanks so much. I would like now, it is my great pleasure to introduce our second presenter. But before I do that, I would just like to highlight a message from the interpreters. To see the presentation, you actually have to pin the AWC host participant, please do that. Otherwise, you basically, it's very hard to see the presentation itself. So please do pin the AWC host to be able to see the presentation. So it is now my great pleasure to introduce our second presenter, who is Dr. Yongnan Zhu. Dr. Zhu is a senior engineer of China Institute of Water Resources and Hydropower Research, IWHR, and she gained a master's degree in geoscience and environment from the University of Science and Technology of Lille in France, and she has a PhD at Ohio University of China. Dr. Zhu, the floor is yours. You're going to tell us about the livelihoods in the water, energy, food nexus. Thank you.
Hello, thank you. Good morning and good afternoon, ladies and gentlemen. I'm Yongnan Zhu from China Institute of Water Resources and Hydropower Research. It's a great honor to be here to participate in the first webinar, Water Energy Food Nexus. I'd like to introduce our research on water energy food nexus in China. Next slide, please. Water, energy, and food are indispensable resources for the survival and the development of a country. Using water, including water lifting, water treatment, is all needs energy. For energy industries such as mining, thermal power also needs lots of water. Water and energy are needed to produce and process food. In addition, climate change has a profound impact on water cycle, energy, and agricultural production. First of all, I'd like to introduce the general situation of water, energy, food in China. Next slide, please. There are many serious difficulties that challenge the development of China, such as lack of water resources, unequal distribution. 80% of water is concentrated in the south part of China, but you can see from the figure on the right, about 60% of farmland, 86% of coal, and 98% of oil resources are located in the North China. Next slide, please. In the meantime, China's energy consumption growth rate has always been higher than the world average, and the fossil energy, especially coal, is dominant. Coal accounts for 66% of China's energy consumption, and it will still account for a large proportion in the future. Next slide, please. Due to the uneven distribution of resources, there is wide competition for water use, such as between energy, agriculture, industries, cities, and ecological water use, especially in northern China. As we can see from the figure, energy bases, food production area, and big cities are highly overlapped. Next slide, please. In addition, it's worth noting that climate change has a profound impact on water cycle, energy, and agriculture. Changes in precipitation and temperature, especially extreme events, will have a great impact on agriculture production, energy production, and demand. It is estimated that by 2050, China's grain production may be reduced by 13% due to climate change, including 4 to 15% for rice, 2 to 20 for wheat, and 0 to 13 for corn. Next slide, please. Now I would like to introduce one of our studies on water energy nexus in the northern China, irrigation water and energy saving in well irrigation district from a water energy nexus perspective. Next slide, please. Now, as mentioned earlier, as a result of the mismatch between social activities and water resources, the northern China, especially the North China Plain, is facing severe water scarcity, which is particularly severe concern in Beijing, Tianjin, and Hebei province. To meet requirements for regional social economic developments, the underground water in this region has been exploited and overexploited for urban, industrial, and agricultural water use. On average, 36 billion cubic meters of groundwater is extracted annually. It accounts for 63% of total water withdrawal for the area. The groundwater in this region has been overflooded for a long period, with the number of wells increasing from 1,800 in the 1960s to 15 million in 2011. In long-term groundwater monitoring results shows that the average shallow groundwater level is decreasing, and the maximum depth of shallow groundwater in Hebei province can reach is 40 meters. And as we know, the deeper the groundwater level is, the greater the energy consumption for water pumping is. In 2015, the power consumption of agriculture well irrigation in Hebei province was 15 billion kilowatt hour. Therefore, we analyzed the relationship, next slide please. Therefore, we analyzed the relationship between agricultural water use and energy use in North China Plain in the past 35 years. And we can see from the figure, the agriculture irrigation energy consumption in Hebei province is increasing in the past years from 2 billion kilowatt hour in 1980 to 15 billion kilowatt hour in 2015. The energy consumption of irrigation is related not only to the total amount of irrigation water, the irrigation method, but also related to the elevation of water pumping. As the groundwater level drops, more energy is needed to pumping water. From 1980, irrigation electricity consumption per hectare showed an average annual rate of increase of 71 kilowatt hour per hectare. Next slide, please. We compare the efficiency of irrigation water and energy use in 1980 and 2015. For producing 1 kilogram of grain in 1980, it requires 0.8 cubic meter irrigation water and 0.12 kilowatt hour of electric energy. But in 2015, for producing the same amount of grain, it requires less water but more energy. It shows a double effect of water saving measures and groundwater level decline. In the past, we only considered agricultural irrigation from the perspective of water saving. Now, when we analyze the system from the water energy food nexus, the results were quite different. And we propose that the irrigation energy use efficiency can be used as one of the evaluation index for water saving effects for irrigation. Next slide, please. As conclusion, I'd like to briefly discuss the current situation and the future of water energy food nexus studies. Next slide, please. At present, international scholars are mainly focused on the study of the relationship between water and energy, water and food, and energy and food. From the nexus point of view, we can better understand the system and promote the efficient use and build a green development strategy for water, energy, and food. I think all the countries are facing the water, energy, food issues, and we need to work together to make our own contribution. Maybe some possible suggestions to sustainable development. And that's all for my presentation. Thank you very much.
Thank you so much, Dr. Zhu. There is an echo. Okay, not anymore. Okay, great. Thanks. I think it's great. I liked how you presented the the challenges in China of the water energy food nexus, and also linked to the impact of climate change. I mean, when I saw those numbers of the forecast for 2050, that for some key crops there will be, I mean, there could be a double-digit drop in food production. When we're talking about China, the volumes of that. So I'm really getting really scared. So thanks so much for your research. Now I would like to introduce, last but not least, our third presenter is Dr. Reni Mayazari. Welcome and thanks so much for joining us. Dr. Mayazari is Deputy Director at the Jasa Tirta II Public Corporation Indonesia, which is a public corporate company engaged in the provision of water and electricity. Dr. Mayazari has a background in urban planning, engineering, and public policy. Dr. Mayazari, the floor is yours. You will tell us about the policy for water management based on the water energy food nexus approach. Thank you. Floor is yours.
Okay, thank you. Thank you very much, Mr. Frederico, as a moderator webinar today. I would like to say thank you for all for coming to my presentation. It's great to see you all in webinar, the second Asia International Water Week. Good afternoon, ladies and gentlemen. Greetings from Indonesia. I'm glad to see you all. I'm Reni Mayasari and I'm from Jasa Tirta II Public Corporation. I would like to presentation about the policy for water management based on water energy food nexus approach in Jasa Tirta II Public Corporation, case study in Citarum River Basin, Indonesia. Water energy food nexus is an approach that aims to integrate all sectors in the natural resources approach, including water resources. Important role in the water energy food nexus. This is the feature of the Citarum River Basin and its interconnected basin located in West Java province in Indonesia, consists of 10 districts. Service area West Java province and Jakarta. Major land use, paddy field, upland, and mixed gardens. Primary and secondary forests cover around 135,000 hectares, equal to 10.2018%. Area is 13,000 kilometers per square. And in the Citarum River, there are 3 large dams, Saguling, Cirata, Juanda, with the separate operator. Next, please. Okay, this is a milestone of Citarum River management, river basin management during the construction period of the 1957, operation of Juanda Dam in the 1967. In the 1970, established of the company Perum Otorita Jatiluhur. After that, 1986 Saguling Dam operation and 1988 Cirata Dam operation. Next, please. After the construction of Saguling and Cirata Dam, there we 3 dam in Citarum, named Citarum Cascade Reservoir, managed by 3 different operator purposes and different purposes. In 1999, changed our company name from Perum Otorita Jatiluhur to Jasa Tirta Public Corporation until now. Our company have vision strengthening the company business as a leading company in Southeast Asia in 2030 in the field of water resources management and its derivative for the welfare and prosperity. Next, please. This is achievement and benefit of water resources management support, water energy food nexus. The first, food security for national through the provision of 4.86 billion meter cubic of irrigation water per year, an area of 552,000 hectares, 2 planting session. The second, a flood control, 3 national energy security, and then resilience of the function of water resources infrastructure, and then watershed carrying capacity resilience through conservation activities and upstream and instream. So we have a benefit drinking water and industrial security through securing raw water supply as much 1 million meter cubic. Next, please. We also have water resource management activities to support water energy food nexus with the water resources operation maintenance consists of operation and maintenance infrastructure, water sources, main canal irrigation, operation of secondary canal, water source maintenance and land security. And the second, monitoring and evaluation and community empowerment consists of walkthrough, water sources infrastructure, biogas project, cleaning area of the reservoir, and visual inspection at 3 dams. The tree conservation and have activities planting and maintenance of vegetation, implementation of weather modification technology to increase water reserve in reservoir. IT development, smart water operation system development, and water sources planning for 3 dam operation, planning for the cropping pattern for paddy. Next, this is 4 pillar of water supply reliability. The first, sustainability of water sources, sustainability of water source, characteristic of water utilizer and need, and operation reliability. This is you can see in the slide. Next. Pillar 1 for the water sources sustainability, we also conservation activities effort in Citarum River Basin by my corporation. In routine, we for the conservation. Next. Pillar 2, infrastructure reliability, water resource infrastructure maintenance activities by our company. This is a list of water sources infrastructure that must be managed properly. So many infrastructure water sources for the support water, food, and Nexus energy. Next, the infrastructure water source infrastructure maintenance routine activities. The picture show the excavation of mud and irrigation canal rather than in drainage of the water irrigation, not hampered by mud of water with. Next. This is formulation of raw water requirement planning process of supply raw water from Juanda Dam. This is the process. The first, we calculate the water requirement for irrigation, and then we draft a governor degree on the rice planting plan contains the table planting plans, planting schedule for 1 year. After that, so we calculate water need other than irrigation water, namely for urban and industrial drinking water, and all water needs are confirmed in the decision of our company board director for the regarding main plan for water supply and use and reference from provide the water. Then this water requirement is required by the team to prepare an operational plan for the Citarum Cascade Reservoir, taking into account local Citarum flow forecast, weather forecast, and sustainability, suitability of the generator hydropower. And everything is accommodated and agree among the reservoir managed. The Citarum Cascade operation plan is legalized. Okay, next. This is operation reliability. We also development of smart water operation and maintenance. The activity of developing the Jasa Tirta II information system in base of the IT. Jasa Tirta II master plan with dealing the activity including completion of the water resources information system, application, improvement and modernization of information system, instrumentation to water sources, development of the customer care for the compliant from the user, application data center development, inventory and asset management, and development of information center technology in stage. The next. This is contribution of our company Jasa Tirta to Public Corporation for national water and food security. The first, control of flood discharge, 2,000 meter cubic per second in the downstream area of Citarum River. Raw water supply of 5.5 billion meter cubic per year. Fulfillment of 80% for the raw water needs for drinking water in DKI Jakarta, and of the 500 million meter per year. 90 of water is provided for agriculture to irrigation area, covering 300,000 equivalent for the 8.2% national rice production and 30% West Java province. If the average rice production 5.5 ton per hectare per season with 2 planting session per year. Jatilur irrigation area contribute 3.3 million ton per year. This is the last slide for my presentation. A contribution Public Corporation for the national energy security. Annually electricity production of the Juanda hydropower plant almost 900 million kilowatt hour. Fulfillment the electricity supply to the PLN Jawa Bali. And the next, and the rest is the electricity. The next. Excuse me. Thank you so much for the time to listen to my presentation.
Thank you, Dr. Mayazari. First of all, well, just on housekeeping, I would please like to remind everybody to please mute yourselves if you're not speaking. If you're listening to the radio, that's fine, but not for everybody. Thank you. Dr. Mayazari, that was very rich and informative presentation. I really loved how you presented the water, energy, food challenges in Indonesia, and especially in the Citarum River, how you presented the institutional setup and the full range of services and solutions up to really the customer. And I also liked very much that slide where you highlight and summarize the benefits of the integrated water, energy, food management. So thank you so much for that. So this presentation concludes the presentation session, and so we now move to the panel discussion. Let me introduce our two distinguished panelists. We welcome Dr. Vadim Sokholov, who is the head of agency in Uzbekistan of the International Fund for Saving the RLC. Welcome, Dr. Sokholov. And we welcome Dr. Chen Duan, who is a professor of water resources engineering and department head of international collaboration at Changjiang River Scientific Research Institute, CRS-RI, a national not-for-profit research body affiliated to the China's Ministry of Water Resources. So we start with Dr. Sokholov. Dr. Sokholov, your activities are, of course, focused on the RLC and the RLC region, let's say, which is, unfortunately, I would say, well known around the world as an ecologically stressed zone. So could you please tell us what you think, if a water, energy, food nexus is a proper instrument for solutions on the ecosystems issues, specifically focused on the RLC? Thank you. The floor is yours.
Okay. Good afternoon, and thank you, Federico, for the question. Yes, it's very important that Nexus today became a practical instrument for solutions for real-time water management. And you know that Central Asia, which I represent in the Asia Water Council, located in a very arid climate. We have water stress everywhere in agriculture, for industries, and for sure for ecosystems, because again, in terms of allocation of water resources and use of water resources, in first term, domestic water supply receive full water, industry also, agriculture with some limitations, but ecosystems always receive water on the remaining factor. From this point of view, if we will use Nexus as a proper tool and instrument for institutional linkages between the sectors, coordination, real-time coordination, so we can receive more water for ecosystems. And I believe that Asia Water Council, as with the main mission to implement smart water technologies and innovations, so using again Nexus as a practical instrument, we can solve these problems. So thank you very much for this webinar and for all presenters who presented real-time practices, how they use Nexus as instruments. So thank you so much.
Thank you so much, Dr. Sokolov, for your views. Very, 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 very important. And now I would like to give the floor to Dr. Duan. And climate change has been mentioned, of course, a few times during this webinar. So I would like to ask you, how can the water energy food nexus, let's say philosophy also, how can it be linked to the goal of becoming carbon neutral? Thank you. Floor is yours. You're muted, maybe.
Now can you hear me?
Yes, please, please.
Okay. Thank you for this interesting question. I think all the three presenters have said that the water energy nexus is the three components of water energy is strongly interconnected, and it's a system itself, but it's all under the influence of climate change. I think as to the the carbon neutral goal, we can also use this system approach to deal with this goal. One way is that I understand is that we can use the water as a restriction for some kind of development of the coal burning plant. If the coal, as we know that the coal burning plant needs a lot of water resources, and then if we use that as a restriction, so we can probably have some consideration of remove the existing coal burning plants, or just cut less construction of those. So this, because you know that, especially in particular in China, the coal burning plant is a large contributor of the green gas costs. So in that way, that if we use water energy nexus approach, so we can contribute to the carbon neutral, the target of to reach the carbon neutral in 2016 or 2050. Thank you.
Dr. Duan, thank you. Thank you so much. Thank you so much. Now we have a little time for questions. And so please look at the chat box. So please leave your questions in the chat box. I just pick one to start. And I think given the topic, I would like to ask this to Professor McCormick. So let me read it. So the water energy food nexus offers promising conceptual approach. However, due to the complex development challenges, there are limitations such as social and political dimensions. How do you think we can overcome these limitations? Thank you, Professor McCormick. What do you think?
That's an easy question. I think we've we've undertaken, well, I think on the social part, I think the takeaway I take, and having worked on some of these aspects in Indonesia and other countries in Asia, but also come back here to Nebraska, one of the things that's just key has been the delegation of responsibilities to the community levels. These are very broad levels here in Nebraska. There's 23 natural resource districts, and that was a very contentious period in the 1970s to really address the groundwater management and reverse the downward trend, and in particularly in the drier parts of the state. But that's where the success came in terms of local elected bodies who had the responsibility. It included the farmers, and of course in the areas where it was not many urban areas. It's a very, very wide state. You got the farmers on these committees that then were involved in management. The state still comes in with regulations, but the idea is not to use the stick until the communities have tried as much as possible to address the problem, and that's been key. Now, to translate that somewhere else, we certainly try in different parts of the world. We're working with partners as to what they can learn from that. But ultimately, it comes down to it's this delegation of responsibilities to the communities and strengthening the communities. That's a key takeaway from managing that, because in the end, there just isn't enough resources and funding to staff and try to do this from the top down.
Yeah, thank you. Thank you so much. Thank you so much for your answer. In the chat, I see one question about the regional situation, like how maybe solutions can be need to be tailored to the regional dimension. And Dr. Sokolov, I'm about to ask you a question, so please get ready. I think the RLC region is quite extraordinary in the way the five countries there in the region are collaborating together on the management of the basin. So I would, and since you're part of this success story, can you please tell us very briefly, really in 3-4 words, what is the secret of success there, so that other regions can learn? Thanks.
Thank you. It's very interesting question. I would say that at the regional level, transboundary level, where we have a few players, for example, like you mentioned, RLC basin, we have 5 countries, even 6 countries, Afghanistan also, but unfortunately it's not officially in cooperation. In these terms, again, Nexus as a tool, I would like to underline that Nexus, we can use Nexus as a tool for finding consensus among the different levels, because in the regional level we should establish consensus between sectors first, second between the countries, and third between the countries and the region and other players, international donors and other very important players. From this point of view, if we will use instruments of Nexus in these different levels, we can achieve the success. So this is my recommendation.
Yeah, thank you so much also for being really so to the point and so sharp. So I see other questions in the chat, but I'm afraid that our time has run out. I really enjoyed this conversation. I would really like to thank the organizers and the presenters and the panelists and all of you, the participants, for your participation. And I would also like to really thank the interpreters for their work. So I now hand the floor back to the AWC Secretariat. Thank you.
Thank you, Federico, for your nice presenting, and all the presenters to preparing well their materials to present. So I think our today's discussion will be very fruitful, and then will be very beneficial for the AWS Secretary to prepare in the upcoming AIW event. So Now I'd like to introduce to all of us to save the date, the fifth webinar on May 18. So the theme will be water and ecosystem, and then we would like to invite for renowned experts from UNESCO and ADB and the French Water Partnership and so on. So we kindly ask you to your continuous interest and participation to the end. We only left 2 sessions to the end. So thank you for your time and your participation. Before closing, I think it's better to take time to taking commemorative photos. So send your position. There was kindly wave your hand, and then yes, turn on your video, and then we'll take pictures on the screen so we can share our time. Please wave your hand and smile. Okay, finally, thank you.
뒤쪽에서.
Okay, keep waving your hands and smile. We will take her on site to take care of all of you. So yes, we have 3 cameras here, so we are now controlling it. Please wait for a while. So yeah, our cameraman is taking pictures all over you. Okay, nice pictures. You're good. And finally, I would like to invite our Vice President for closing remarks as a final program.
예, 오늘 물, 식량, 에너지 넥서스를 주제로 한 제4차 AIWW 온라인 세션에서 고귀한 의견을 나누어 주셔서 감사합니다. 국제 신재생에너지협회는 물, 에너지, 식량 넥서스는 정책, 개발, 연구에 있어 글로벌 아젠다의 중심에 있으며 자원 한계에 도달하는 국제 상황에서 빠르게 증가하는 자원 수요를 충족할 수 있는 결정적 역할을 담당할 것이라 한 바도 있습니다. 오늘 논의에서 살펴보신 것처럼 각 나라들은 저마다 처한 상황에 따라 물, 에너지, 식량 등 연계된 모든 자원의 다각적 측면의 자연 효율성 증대를 위한 정책 혁신 기술 개발을 추진 중입니다. 이러한 국가들의 WEF 추진 정책, 혁신 기술 개발 경험은 더욱 활발히 공유되고 다양한 협력을 통해 추진되어야 합니다. 오늘 논의가 그러한 의미에서 소중한 계기가 되었기를 바라며 아시아 국제 물 주간을 통해 더 큰 성과를 맺고 글로벌 2030 목표 달성에 기여할 수 있기를 바랍니다. 다시 한번 참석해 주신 여러분께 진심으로 감사드리며 남은 세션에서 다시 뵙기를 기대합니다. 감사합니다.
Thank you for all. So now we officially close our event and see you. Hope to see you again. Bye bye.
Everybody, wait a second. Regarding the material, the secretariat will upload to the speakers. The material, and please don't leave in this. The Zoom. And if you stay in this Zoom, you can download. It takes just 5 minutes because we need changing the PDF and something. And wait a second, and you can download in 5 minutes. Okay.